Acceleration is an interesting thing. It is the change in velocity over time. Since velocity is the change in position over time, acceleration has an exponential effect. It takes 1 second accelerating at 1 g to fall 16 feet, but it only takes 10 seconds with the same acceleration to fall 1600 feet. As you can see, the amount of time accelerating squared is proportional to the distance traveled. There is an equation for this. Half the rate of acceleration multiplied by time squared equals the distance traveled. You can also add initial velocity and position to the equation, but that is not necessary right now. Space travel takes a long time. It takes a week to get to Luna, months to get to Mars, and nearly a decade to get to Pluto. This is because when we travel through space, most of the time is spent coasting, just floating along at a certain velocity without accelerating. This is because of fuel restraints. But for the sake of argument, what if you could accelerate indefinitely? The thing about acceleration is that it really builds up quickly. If you were to fall under Earth's gravitational acceleration for 1 year, you would be moving at the speed of light and have traveled half a light year. Well, not if relativistic effects came into play. Because of time dilation, you will be stuck in slow motion. Also, because of relativistic mass, you will have more mass. Because of F equals ma, with a constant force, you will have less acceleration, but that small amount of acceleration feels like more because of the time dilation slowing you down, but not slowing acceleration down. The result is that you could go on any length trip and constantly feel acceleration, something important to prevent muscle atrophy. Also, trips of many light years would be condensed by time dilation. Continuous acceleration would be the best way to get through space because of its speed. But what kind of power source could support constant acceleration? None of our current methods. There are some other methods that are stronger, like nuclear pulse propulsion, nuclear fusion, or matter-antimatter drives, but none of them could support acceleration forever. Maybe some could support it for a while, but forever would require infinite energy. All in all, continuous acceleration would be the best way to get through space if it weren't so impractical. It is impossible to generate the amount of energy required for interstellar travel, but maybe for short interplanetary trips it could be employed.